Hello and welcome back. In this episode, we will implement our fluid particles now. So let's jump back to Visual Studio and let's create a particle class. I already did that, as you can see here. Just create a new particle class in the same folder. I'm just gonna disable GitHub Copilot again. There we go. And now we can create our particle class. So let's do that. This particle class will have a constructor, of course, and it's only getting a position. There we go. And this might be a little surprise, because the particle class only has a position, a previous position, and a velocity, and maybe a color too. I guess we can set a color to, just gonna check, is there a vector? Right, there's a vector 0, then let's use this one, vector 2 dot 0. There we go. Yeah, I think we can use a color there too. And I also have a specific color I want to use. So this dot color is equals to this color. This is a bluish color you see in my you saw in my videos, in my video where I explained the algorithm and what we're going to do in this tutorial. So that's the blue color. Yeah, that's already everything we need for the particle class. And now we can add our methods we need for for the simulation. So let's jump to the simulation. And I'm gonna add the first method I want to add is the predict positions. And what we are implementing right now, if you look at the paper, if you take a look there, this is predict positions is in the line 6 to 10 right now. Maybe I'm gonna blend that algorithm in. It's in the line from 6 to 10, and we are now only implementing everything we need to move our particles. So we only need the predict positions and the compute next velocity, which is in the lines 18 to 20. All right. Yeah, predict positions. Here we go through every particle. So this dot particles. Oops. Oh my god. What's that? This dot. Okay. Yeah. I have to create the particles too. So let's create the array first. This dot particles is equal to the array. Then I'm also setting the amount of particles already. I'm gonna set this one to 1000 and yeah, now that's everything. Okay, and then in the for loop, this dot particles dot length and I plus plus. All right. In this for loop, we have to calculate, or we have to set the previous position again. So this dot particles I dot breath position. How did I call this? Breath position, right? Is equal to this dot particles y dot position dot copy. Yeah, and I'm gonna explain why we need a previous position and a current position when we did that, when we have some particles flowing over the screen. But yeah, for now I'm gonna make sure that everything works. And the next thing is this dot particles dot position is equal to, and here we need to add the current position. So this dot particles, current position of the particle, position with the velocity. And here I think I'm gonna make a new variable, and this will be position delta. And this is the velocity times the delta time. So this dot particles y dot velocity times the delta time. And here we can implement or add a velocity damping to our particles, and I think I'm gonna do this. So let's just create in the constructor a velocity damping variable. And this is velocity damping. I'm gonna set it to 1, so there is no damping right now, but maybe we wanna change that later. When we want to have a kind of a higher viscosity, then we can use this parameter to make it even more viscous. Okay, that's for this method. And now the only method we need to implement is the compute next velocity, and I think then we are already set to spawn some particles. And the compute next velocity will compute the velocity from the current position with the previous position, and we are just subtracting one from each other, then scaling the subtraction by 1 divided the delta time, and yeah, that's our particle velocity. I think that's quite how the worded integration kind of works, and that's also why it's possible to restrict particle positions so easy. You can just set the position and it just works. And that's making implementing shapes, for example, collision with shapes, really simple, because you just need to push out the particle out of the shape and that's it. You don't need to do anything. Yeah, compute next velocity. Let's just copy this for loop here and paste it. And then we have the velocity. First, I'm gonna say, yeah, that velocity is equal to, maybe, yeah, no, let's do it like this. We scale the subtraction of this dot particles dot position. So we're subtracting the current position with the previous position. Oh, previous position. There we go. And then it's saying we want to scale this one by 1 divided with the delta time, and that's our velocity. Then we can set the velocity to the particle. So this dot particles position I dot velocity is equal to velocity. There we go, and then we have our compute next velocity. So let's change that. Velocity. There we go. All right, and then we can. I think we also can add a drawing for the particles here. So let's do that too. Just gonna copy this for loop again, paste it, and then I'm gonna say let the position is equal to the particles dot current position, and then I'm gonna say draw utils draw point at the position with a radius of 5 and the particle color. So I'm gonna save the particle color too, like this. Alright, and then paste the color in, and there we go. Yeah, I made that wrong here. Alright, and that's our draw function. We don't need to do anything more in the draw function. The only thing we need to think about now is how we want to add the particles. I'm usually doing this with creating a rectangle of particles and then spawn these in and see what happens. And I think we can do that here too. So I'm going to create another method, and this will be called instantiate particles. And here we have a for loop. So I'm just going to copy this for loop again. But since it's a kind of a rectangle, I'm going to change these eyes here to a X, and this one will be how many particles we want to have. First I'm going to copy this for loop again, because again we want to have a rectangle. And now I have to calculate how many particles I want in the X direction and how many I want in the Y direction. And I'm gonna do that really simple. I'm just saying, alright, give me all the X particles, which will be just the square root of amount particles. And that's it. And same for Y particles. And that's it. We're not gonna have, probably, if we say, okay, we have 100 particles, then square root of 100 is 10, so we get 10 X particles, 10 Y particles, 10 Y iterations, and 10 X iterations. If we have a number which isn't, well, where you can't really take the square root, then, I mean, to get a simple integer, there might be a little error, but I think that's totally fine. We can just ignore that. If there's a particle not in the list, doesn't matter. And yeah, I'm gonna replace, I'm gonna replace this one now with the X particles and this one with the Y particles. There we go. And now I'm gonna calculate the position where I want to place my new particle. So let's create a new variable called position with a new vector. And here I'm saying X and Y. And I'm gonna leave it like this. We're gonna add something to this one too, but first I wanna show you how this will be instantiated. And then we can say this.particles.push. And here I'm saying new particle with the position. Yeah, that's everything, I hope. I'm sure I made some mistake. Let's see. Yeah. First we need to call list.instantiate particles. And we also need to include our particle JS file into the scripts. So let's import that particle.js. Alright. And let's jump to the browser, save, refresh. And there we go, we still have our drawing from the last episode. And here you can see our particles, 1000. Well, yes, we need to add some things to instantiate them right. But first I wanna remove these drawing things here. So let's go back to Visual Studio, go to the background, and I'm gonna, I think I'm just gonna well, actually I can delete everything. All right. So and if I go back now again, then you can see our really small rectangle of the particles. Okay, yeah, we need to change some things in the instantiate method. And we are adding a offset between those particles. So let's go back to Visual Studio again. And this offset will make sure that the particles have a kind of a padding in between. And yeah, I'm just gonna say this padding. So I'm gonna say offset between particles. You can also call it padding, I guess. Probably that's the better name for that. But yeah, I'm gonna stick with this one. And I'm gonna multiply the X position with that and the Y position with that. And now if we go back to the browser, don't forget to save and refresh. And now our particles are a little bit better placed. But still, well, maybe we wanna change the position of the rectangle, right? Maybe we wanna have these particles right there, or whatever. We need to add something there too. And I'm gonna add another offset variable where I'm gonna say, okay, I wanna place this rectangle right there or right there. So let's go back again. And here I'm gonna add a new one, and this will be offset all particles. There we go. And this will be again a new vector 2. And I'm gonna say 750 and 100 at the position. And this one, I'm gonna add this one here with a plus sign and the X component. All right, so this is the X and this is the Y. And there you go. All right, and I think now our rectangle should be placed somewhere else. So let's save again, go back to the browser, and let's see. All right, that looks good. If I increase the amount particles and I refresh, then we see yeah, the rectangle is expanding. When I set the offset a little bit higher, you don't need to do this. I'm just going to show what is happening. If I set the offset between particles a little bit higher, then we see that the particles now have a offset in between. This is quite handy. We will see that later when we are finally implemented everything to do our first really fluid run, and then you will see that the higher the particles are stacked together, or yeah, or the less the offset between those particles is, the higher the kind of a explosion it will be, because the density will be so high that the particles will be pressed out in every direction, and that's usually not what you want. So we need to set the offset between those particles by hand then. Okay, yeah, what I want to do now is adding a velocity to our particles so they move around. And we can do that quite simple too. I'm gonna save this particle here. I'm not gonna push it. I'm first saving it to a new variable called particle. And yeah, I'm just gonna copy this one, paste it in here. And then I'm saying particle dot velocity is equal to scale. So I'm gonna scale a vector now, and I want to set it to a random direction. So I'm saying new vector 2, and the x component is minus 0.5 plus math.random, and math.random gives you a random number between 0 and 1. So the x will be between 0.5, minus 0.5, and plus 0.5. And yeah, and same thing for the y component. All right, and then I'm gonna scale it by, yeah, I know, I don't know, let's say 200. And yeah, of course, yeah, I already almost forget that we need to add the update functions too, because without that we don't see anything. So I'm gonna call here compute next velocity with the delta time, and before that we are predicting the positions also with the delta time. All right. Yeah, and I think that's everything. Oh, I forgot to push the particle actually. Good. So, let's jump to the browser, refresh, and we don't see anything. All right, and why? It's because copy is not a function. Probably, oh yeah, and I don't know how I got that, but somehow I forgot the position delta in here. I don't know how this was happening. Well, anyways, let's go to vector and add the copy function here too. And I'm gonna return just a new vector with this dot x and this dot y. So yeah, this dot x and this dot y. All right. And if we go now to the browser, don't forget to refresh again to the browser. And there we go. Our particles are moving. It looks really, really funky. That's because we are not clearing our canvas, and we will change or fix this now. And we need to go to the main HTML. So in the main HTML, we need to, oh, 1 second. Yeah, so sorry for that. In the main HTML, we are adding a new function. I'm gonna add it right below the main loop, and this will be function clear, and I'm gonna just say ctx.fillStyle is equal to white, and ctx.fillRect. Actually, I'm not gonna use white. I'm gonna use the same color we have now in the canvas, but I'm gonna change that in a second. First canvas.width and canvas.width and canvas.height. All right, and then we have the color somewhere. Where is it? There we go. That's our color I want to use. Okay. Fill style. All right, and then we need to call it again, of course. And I'm gonna do this right before the background update and draw. And now if you go to the canvas. Then we should see our particles moving around, and they're doing that. That looks cool. All right. Last thing for this episode, I'm gonna add a small boundary collision check thing, that the particles will move inside of our canvas and will be rejected from a border, from a wall like this one. And yeah, what we're gonna do is we will just flip the component of the velocity of the x or y component, depending on which border it is, with -1, and then the particle will go in the other direction. Alright, so let's do that too. In the simulation class, I'm gonna add world boundary. This is a new method. So world boundary. This will not have a parameter, but it will have a for loop again. So I'm gonna copy this one. And then I'm gonna retrieve the current position. So this dot particles dot y dot position. And then I'm gonna say if position dot x is smaller than 0, then I wanna flip the velocity of the current particle, especially the x component of the velocity, with -1. And I'm gonna do the same thing for all the other components. So I can copy this one. This will be this will be position.y. And here the velocity, of course, needs to be changed. Then we have if the position is bigger than the canvas dot width. Oh my god, what's that? Canvas dot width. All right. Yep. And then yeah, I'm gonna flip this one too. Actually, we can, this one, can we just copy it into this one with a or statement? This should work too. But I'm gonna leave it like this now, because we might need it later in this configuration. And then we have the same for position Y. And of course I need to say canvas.width. Got that. And then I need to say canvas.height. And also need to change the Y component. Okay, and I think that's now everything. So, yeah, and of course I need to call this method too. I'm always forgetting that, I don't know why. So let's call world boundary. And now this should work. Oh no, it won't work. I forgot to change this one to this one. Okay, so just change that. I just tested that because, yeah, I want to make sure that I don't search for errors that long. So I just tested this one, and yeah, I made a small mistake here. This one needs to be flipped like it is right now. All right, but now we have everything. So refresh and go back to the browser, and now we will see that our particles are, well, can't leave our canvas now. And that's what we want to have for this episode. Okay, and now if you're still with me, I'm trying to explain why we are using this weird previous position and position and why we are computing the next velocity. So why they are using a predictive position compute next velocity scheme here. The reason is because if they are predicting a next position, okay, so they are using the predicted position to move the position. You know, well yeah, no, sorry. I mean, the particles, or yeah, the particles are first moved, all right, according to their velocity. So they are first moved, then the resulting position can then adjust it for example, collision avoidance or whatever it is, and um, with this one, with the adjusted position, then a next velocity is then calculated. All right, and that's how this works. If you use a normal integration scheme like semi-implicit Euler, then everything is just done in one run. All right, you have the force converted to acceleration is converted to velocity, and the velocity is converted to the position, and this is all in one method. And with this system here, you have two separate methods to calculate these. First the predict position, and later the compute next velocity. And the compute next velocity is when I'm right at the really end of the algorithm. I need to check that. Let me see. Yeah, that's at the really right at the really last step in the simulation, and then the velocity is actually calculated. So we are predicting a position from the previous velocity, and with this velocity we can with this new position we can check, all right, if there's a collision, then just move this, and with the new moved particle, for example, out of a collision or whatever it is, with this moved particle or with this moved position, we can calculate then a new velocity out of that. And that's making the simulation a lot more stable. And I think that's the same thing what Whirlid also does. But yeah, I need to check that sometime. Also, we are also doing a glove simulation in the future, so then you will see a kind of similar scheme. And yeah, this method here is also quite often used, not in smooth particle hydrodynamics, but in position-based fluids too, and in position-based dynamics. We will implement that in the future too, and then you kind of see the same techniques again. All right. Yeah, that's it for this episode. How many minutes? Or yeah, 43. All right, that's okay. I would say. Yeah, I hope this predictive compute next velocity and so on was a bit clear. And yeah, in the next episode we will implement a neighbor search with the hash grid. If you did that tutorial, if you watched the tutorial about my rigid body simulation, I did a hash grid there too. This one will be slightly different because we need to handle particles, not bounding boxes. It's actually gonna be a little bit easier. But yeah, we need to do that for our optimization without a particle hash. I mean, without a particle neighbor finding algorithm, it's going to be really hard to do any particle simulation. And yeah, that's for this episode. Thank you very much for watching. Sorry for my little mistakes. I still make them. I'm trying to avoid that as best as possible. And also my well, my English is not that good as it should be sometimes, but I hope it's fine anyways. So, all right. See you in the next one. Have a nice day and bye bye.